Hi, I have a NordicTrack GX 2.0 exercise bicycle, and I was riding it the other day, and all of a sudden the controller display unit started resetting itself continually and stopped functioning. So I decided to do some troubleshooting. I took the plastic skins off the exercise bike, and I'll walk you through how I did some troubleshooting and a quick fix solution I came up with on how to get the exercise bike back working again. Here's the exercise bike with all of its plastic fairings off, and it's actually, once you start looking at it, it's not too terribly complicated. I'll point out some of the areas and how I troubleshooted the wiring harness to find out what actually is going on and which components are wired to where. And then we'll take a look at the control unit, and I'll explain how I did some of the troubleshooting with that. In front of the bike, there's an AC adapter. On the adapter, it's 12 volts, 1 amp, and we'll follow the wiring back and see how the motor and the Hall's effect sensor is wired in, and we'll try to do some more troubleshooting, see what's going on. On the pedal assembly, if you look really close, there's a Hall's effect sensor and a magnet on the pedal wheel assembly, and then there's a two-wire lead going back to a wiring harness that I'll show you in a moment. This is how the exercise bike gets data on how fast you're pedaling, distance, calories. Part of the calorie calculation is done with this Hall effect sensor. So let's keep on looking back toward the rear of the bike. Taking a look at the sort of the business end of the exercise bike, there's a cast iron weighted wheel assembly back here, and at the very bottom there's a looks like an adjustable skid, but actually there's some magnets on that. So I haven't seen anywhere where it's applying any friction to the cast iron wheel, but there is a magnet. We'll look at the other side and show you how that skid assembly gets moved to increase and decrease the tension on this weighted wheel. Here's the main wiring harness. Part of that harness goes from the AC adapter, 12 volts, 1 amp, comes back and feeds into the main wiring harness, and also the Hall effect sensor is coming into the main wiring harness here. And then up in the top portion, it's sort of hard to see because everything's black there, but there is a motor assembly there with a lever arm on it that moves that skid closer to and away from the main weighted wheel, and that's how the tension adjustment is done. We'll take a look at that in a little bit more detail here in a moment. I removed the motor assembly from the exercise bike, and you notice the wiring connector there and the lever that connects to the skid that increases or decreases the tension. We'll look at the other side of the motor here momentarily, but the assembly almost looks like it's an RC servo motor. But let's take a closer look and examine this motor a little closer. The motor over to the other side, notice there is a DC motor. There's two wires, the yellow wire and the blue wire, so it's not a servo motor. It looks like it's just a DC motor because there's two leads there, and those two leads are tied into the main wiring harness. Let's flip the motor once more. Okay, here's the other side of the motor assembly. Notice there's 3 more sets of wiring, and those wires are going into what looks like a 5K potentiometer. So obviously what they're doing here is they're various positions as the motor positions that tension up against the wheel, either closer in tension or way in tension. It changes the reading of that potentiometer, and it's more than likely what the exercise bike is using to determine calories and things, along with the Hall effect sensor to determine your calories, your distance traveled, and such. So increase in tension is going to increase your caloric intake on the bike, and loosening the tension is going to decrease the amount of caloric intake you're going to be while you're pedaling. So let's hitch the motor back up and then apply some voltage to this motor and do a little testing to see if the motor is functioning and to see if we can actually control the forward and reverse direction of that motor. Okay, I have the motor hitched up to a battery source, and when I apply voltage in one direction on the DC motor, notice the cam and lever move one direction, and if I reverse the voltage, then the cam rotates, moves the skid closer to the wheel. So in this particular case, I know the motor's working, and now I know how the tension is applied to the motor, and nothing fancy. The controller probably uses pulse width modulation to bump that motor a little bit at a time to move the skid closer to or away from the weighted wheel. So I know that that's working, and so the problem must lie, unfortunately, in the controller display unit, and probably that's going to be where the major malfunction is going to occur. So let's go take a peek at the controller. I removed it from the exercise bike. I put it on my workbench, and we'll do a little bit of troubleshooting with that. Okay, here's the controller unit disassembled. I have a bench power supply, so I set up a constant current setting, and I traced back the wire harness and found out where the positive voltage and ground were coming into the controller unit, and I applied some voltage, 12 volts, to the unit, and right away I got an overcurrent indication. So I disconnected. On this particular controller, there's an iPod input connector, and the speakers and the touchpad. So I disconnected the touchpad, the speaker assembly, and I removed the wiring connectors from the iPod dock. Reapplied the current, and unfortunately I was still getting an overcurrent indication on the meter. So if you look real close on this circuit board, there's not very many discrete components. It's all chip level. So there's, other than a few capacitors, there's not too much terribly to fix or replace on this. So looking at this right off the bat here, it looks like this controller is shot and there's not much I can do to repair it. So I did a little checking online and realized that a replacement unit for this controller display from the manufacturer, they're looking over $300 for a replacement. So there's absolutely no way I'm going to pay that kind of money to replace this. So I had to come up with some alternate solutions here to get this working. So let's take a look at what I came up with. So looking at all the components on the exercise bike, we know the Hall effect sensor is there, and we looked at the wheel assembly and the motor. The motor's working. So at first I thought, geez, this would make a great microcontroller project. I could take a microcontroller, inexpensive microcontroller, either an Arduino or a TI MSP430, and write some code and measure the tension or the ohms coming off the potentiometer on the motor, and count the number of turns on the Hall's effect sensor, and I could write my own little program and do some kind of a display. But then I'm really busy with some other projects right now, which you'll see the result of. So I figured, you know, I got to get this exercise bike working, and don't have a lot of time, and I don't want to dump a ton of money into repairing this thing. As you can see, the actual mechanical parts and electrical parts are fairly simple, other than that controller display unit. So I had to come up with a real easy solution. So for around $15, I came up with a pretty quick and dirty replacement to get the bike working. I'll show you that here in a second. Okay, here's what I came up with. I went up and made a quick trip over to Radio Shack, picked up a few components, and wired in a dual pole dual throw switch, a momentary push button switch, a AC to DC adapter, and a couple of leads going down to the wiring harness. So I know that the DC motor is working, so I basically wired it up so that by flipping the two-way switch, I could increase the tension with the switch going one way, and then bump the momentary switch to increase the tension. Or to decrease the tension, I could bump the two-way switch the other way, bump the momentary switch, and I could decrease the tension on the wheel assembly. So pretty interesting. About $15 worth of parts. Actually, for me, it was a little less. I had a few parts lying around the shop, so put that together. On my website, on my blog, there's a wiring diagram of how I wired in the switch assembly to the actual bike, and I'll show you the wiring harness here in a sec. Okay, here's the wiring harness coming out of the tube on the exercise bike. It's 10 leads, and if you remember, the wires coming off the motor were blue and yellow, and those positions are 1 and 2 on the wiring harness. So what I actually did was, coming out of my little control box, I just tied in to the blue and yellow wires with some female jumper wires, and that way if I ever decide to come up with a microcontroller solution, I can simply remove those and plug right back into the same wiring harness. So it actually works really well. I can ride along and increase the tension or decrease the tension by just bumping the momentary switch. So all in all, it took me about an evening of just putting some stuff together and wiring it up and testing it out. Works really great. Later on, when I have some time, I will put together a microcontroller solution. But again, if you go to my website, my blog, and check it out, I have the wiring diagrams and some photos of how I did the assembly. And hopefully, if you run into the same situation, you can use this as a quick fix. Thanks a lot.